All right, welcome back. This is the third video in the series. The links to the other videos are in the description below, as is any code that I'll be using today. All right, so what we'd like to do now is I'd like to set up both of these LCD screens. This is a 16 by 2 and this is a 20 by 4, and we're going to set this up on the main I2C bus. We're using a Teensy 4.1. So let's just jump right in. If you were following along in the last video, we used the alternative pins, 17 and 16, to run a secondary I2C bus. So if you were following along, I'm going to just recomment these lines here and these lines here, and that way we will be using the default pins. In the link below and the code below, I've got a link to the PCRduino Teensy pinout. So we are now back into Teensy 4.1, and we're going to be set up in the SCL and the SDA. The SDA is A4 and the SCL is A5. So just to make sure, the SDA is my yellow pin and the clock pin, the SCL is my blue pin. And so this is the really nice board by Patent Robotics. I love these. The A4 pin, that's the yellow, that's the SDA, and then the A5 pin is my little yellow signal pin here. All right, so now if I upload the code, oh my goodness, I forgot to switch it. I was running a Teensy 3.2, but that's a Teensy 4.1, of course. So we got to go to Tools, Board, PCRduino, change the board, and then while I'm at it, just make sure the port is set to the right port. It's going to give you this bootloader port until you compile it. So once we compile it, then it tells me the port is COM13. So just make sure your port and your board are connected properly. If you recall from the code, we have this while bang serial. I just do this so that I can kind of control when it starts. So when I open the serial, then this while loop will stop running and the rest of the code will run. So as soon as I open up the serial monitor, you'll see that my hello world message starts. There it is. And then the time starts printing milliseconds. All right. So we verified that the board is working. Now let's see, how can we connect a second board to that same port? All right, for this, I'm going to show you how to make the I2C little ports with a breadboard. So let's do that now. All right, before I dive into the details of what's going on here, I just want to show you what we're going for. We have two LCD monitors, and they're both reading exactly the same thing. And this is not what we want, but this is like the first step in the process. The code that this is running is not down below in the description, but I just wanted to show you what that code looked like. If you haven't been following along in the previous videos, then this may not be very instructive for you. But the idea here is that we have set up an LCD object at this address, and we ran scanner. Maybe we should run scanner right now and just see. We ran scanner from the wire library, all right, and let's take a look at what it says. It says, now there are two devices, right, but notice it only shows up as one device at OX27, OX27, okay? If I unplugged one of my LCD screens, it would still say one device. That's because both of these devices have the same address, and they're both connected through this kind of spaghetti breadboard wires here. They're both connected to only one port, a single port here on the Teensy 4.1. So that's what we want. That's what we'd love to have. One connection, right? Only one set of wires going to the I2C port, but it can run a multitude up to 127, I think, 127 devices here. And sorry that it's not showing up very well on the video, but it's showing up perfectly fine here where I am. So let's take a look at what this spaghetti is. So notice that I have my, where is it here? I've got my ground, my VCC, my SDA, which is my data, and my SCL, which is my clock. I've got those four wires running here, okay, to a breadboard, and then I've got the same happening here. My ground, my VCC, my SDA, my SCL. These four wires are running to another piece on the breadboard. So that kind of simplifies things there. So I am simply going to unplug these here one at a time and just show you what's underneath here. So if you needed to build it yourself, you can. All right, so I'm going to take these devices, move them out of the way for now, and just kind of let's talk about what we have here. I've got the main SDA and the SCL wires coming from the motherboard to the breadboard, all right? And that's going to feed these breadboard columns here. I'm going to go ahead and unplug that again, just so you can see exactly what I've got here. It's a very, very simple circuit. And basically, these are just really long male header pins. Now, they're doubly long. They're long on both ends. Typically, they're long on one end and then short on the other end. So you have to buy these kind of special. But they're designed to go into boards like this, into the breadboard. I've got 3 rows of them of 4 pins. And remember, my cable here was plugged in. This pin over here on the outside is ground, and the second pin is power, and then the third pin is SDA, and the fourth pin is SCL, the clock pin. So notice that the ground pin, they're all connected to each other, but the ground pin doesn't go anywhere. It's just kind of just connects all of the pins that you plug into ground. The power pin, which is my second row here, is actually connected to this power bus way up here. So I just grabbed a little yellow jumper wire and I'm jumping the power pin, which is the middle pin, up to this bus. And now I'm taking 2 4.7 kilo ohm, 4.7 thousand ohm resistors, and I'm connecting the SDA pin to the power bus through that 4.7 kilo ohm resistor, and I'm doing the same thing for the SCL bus. And so what we have is we have 2 4.7 kilo ohm resistors connecting SDA to power and SCL to power, and that's it. If that's confusing to you, let me show you a little helpful site here. So for multiple devices, there's a little page here on Adafruit that talks about how to set up I2C devices with pull-up resistors. Okay, and this is the asset. This is the picture from that website. All right, so here's the controller. This is our Teensy, and here's our target. This is our LCD screen or whatever. And again, you have to know the address. It's OX something something. And then we have a pull-up resistor from VCC, which is our power, to SDA. And we have another pull-up resistor from VCC to SCL. So that picture here is exactly what we have here. All right, I also want to point out that this little guy here, this breadboard piece, is going to be fabricated as a printed circuit board. And this is my design over here, mine and one of my students, past students, Sid Coachman. Great guy, Sid. Hi there, Sid. How you doing? We have the same thing here. All the grounds are connected. The 5-volt power runs a 4.7K resistor to the clock pin and also the SDA pin, another 4.7K resistor to the SDA pin. That little circuit board that Sid and I developed is exactly what you have here on the breadboard. Of course, the circuit board is little tiny, and it's so much easier to connect than a breadboard. But if you have a breadboard, you can do it this way. And so what we need to do is we need to connect the ground wire, the power wire, and this signal wire. And this signal wire is our data. And this signal wire, the blue one, which is our clock, we need to connect that to these pins over here. And it does not matter where you connect them. We're going to connect it to this back row or to the middle row or to the top row. I think for ease of use, I'm just going to connect it here to the top row. So if you recall this outside pin here, these are all our ground pins. So I'm going to take our cable, 3-conductor cable, and I'm going to plug the ground pin there, like so. And then I take my clock pin and I plug it in here. So now with just one cable going to the breadboard, we're able to now connect, in this case, 2 more I2C devices because we have 2 more rows here. I could add a 3rd row and connect a 3rd device, or I could jump all my wires, one down to one, down to one, down, and then I can connect 3 more rows, and I can continue to daisy chain and keep doing that until I had 127 devices, which I believe is the maximum number of I2C devices you can connect. All right, so next we grab our small LCD board. Again, I'm going to grab ground, my power, my data, and my clock. And in that order, and making sure that the black ground wire gets plugged in to the outside, like so. So all my grounds are connected. And then notice that I got power here, but it's not running. Okay, and then I connect the clock pin. All right, so now let's upload our code. Now this code is not down in the description. This is the code we've been using for the last 2 videos. So I'm just going to upload it here. And notice that here, the while bang serial, this is going to pause until we open up the serial monitor. So nothing's going to happen until I open the serial monitor up here. So we're almost done compiling. All right, there it is. Let me make this window just a little bit smaller. I don't know where that serial monitor is going to open. Let's just get ready for it. Okay, so now it says, hello world, start me up. So it's working just like it was before. We're printing the time now, and we're printing hello world. Everything looks just like we left it. So now let's move back to here, and let's attach now the other LCD screen. And now it's super easy. We're just going to connect ground to ground. And the big board again cranks up. And then we're going to connect our clock pin here. Okay, and now, I don't know if you can see, but it's a bunch of garbage, right? There's just a whole bunch of garbage there. And that's because this big board was not plugged in when we initialized the LCDs. So let's take a look at that code. So inside of the setup, we need to run the LCD initialization function, and we missed it on this one. So let's upload the code one more time. I believe my serial monitor is open, right? So it's just going to run automatically as soon as we upload. So here we go. Uploading code, and hello world, start me up is coming up on both of them here. Now these are producing identical outputs, which is what we expect, because both of these have the address of 0x27. Okay, that hexadecimal address is the same for both of these devices. So anything that has that address, which is usually LCD screens, if you had 5 of them, you would have 5 displays of the same thing. Now what we want to do is we want to actually have 2 different monitors that run 2 different outputs. And let's see how that's done here. I guess first of all, I'm going to show you the back of these LCDs. And I just want to point out these jumpers here, A0, A1, and A2. These are little pads, and these are the 2 A0 pads, then the 2 A1 pads, and the 2 A2 pads. And there's a little gap in between. If you connected a piece of metal across A0, that would short those 2. It's sort of like a little switch, and you can short that, and if you do, you'll change the address of this board. So with the pads like this, which are open, they're not shorted, this has a particular address, and it's this over here. It's OX27. I tell you what, we're going to close the LCD I2C. I'm just going to minimize it, I guess. And then let's open up the one that's actually down in the description below. This is the multiple I2C LCD sketch that I created over there. And that's down in the description. Okay, so let's take a look at it. And you can scroll down in the comment section in the header to look at this little table. So the idea is if they are all open, if all of the pads are open, in other words, A0, A1, and A2 are not shorted, then the address, the ID address, is 0x27. But if I were to put a piece of metal across A0, for example, if I were to short A0, and A0 is the only one that's closed, then my address will be OX26, and so on. So we can get 8 different addresses with the same board by simply putting a glob of metal on there. Let me show you how I've done that. So here's another board that I've modified. And so here I just put a little dab of solder which shorted the pins on A2 So whenever I connect this board, A2 is shorted, so the board's address will be 0x23. And so in this way, we can have two boards that have connected to the same I2C port, but have different addresses, and they are differently addressable for that very reason. While this old board, or sorry, while the unmodified board, right, this is the 0x27 address, while it's still connected, let's run scanner one more time just to show you what that looks like. So if you weren't with us before, we can find the scanner sketch by going to File and then Examples. And if you scroll way down to the very bottom, you'll see a wire folder, and then in there is the scanner sketch. So we run that. Let's open up the serial monitor, and we can see that it only shows one such device at 0x27, and that's because both of these have 0x27 addresses. So as a result, we only see one of them here. Okay, if I unplug this one, you'll still see the 0x27 because this one is still running. But now if I plug my other one in that has the A2 shorted, okay, and again, ground to ground. So I'm just going to do that now. Plug in my 3-conductor cable first, okay, and then I plug in my clock pin. And now when we look at the screen, we'll see there's an 0x23 and an 0x27. So now it recognizes two different LCD screens. And now let's make use of that. I'm going to close the serial monitor. I can minimize that. And now let's take a look at our multiple I2C sketch, which is again in the description below. All right, so we begin with the include just like normal. We created an LCD. This is the same thing that we've been doing before. And so this LCD is the name we have for the little guy. And that address is set up as 0x27, and it's 16 rows and 2 columns. Sorry, 16 columns and 2 rows. All right, now let's make another object. We'll call it LCD2. So we invoke it by this little constructor here. And this one, we know, we just saw in the scanner, right, has the address of 0x23, and it is 20 columns and 4 rows, because obviously it's, it's a bigger machine. So either you run scanner or you come up here and you take a look that if we short A2, it's going to be 0x23. Somehow you have to find the address of your LCD screen or whatever other I2C device you're making. All right, so that's a big part of it. And now when we come down, basically this is the same code we've been running, LCD initialization, LCD backlight, and so on. And then we could do the same thing for our LCD number 2. Remember, this is the name LCD2 that we created. Those are the same names. And we do exactly the same thing. Here we can turn on the backlight, set the cursor to print hello. This is saying LCD2, and it says start me up. So I'm going to go ahead and open the serial monitor so that it will start running immediately. Let me move this guy out of the way. Okay, so let's upload the code and let's see what happens. All right, so we do this. We have 2 different LCDs, and so when it pops up, it's going to say LCD number 1, LCD number 2. So they're recognizing 2 separate devices, and this one gives the time with the message LCD1, and this one gives the time with the message LCD2. So 2 different outputs, 2 different devices, but we all of this is using just one I2C port. Really, really cool. How neat is that? Hey, my board arrived and we were able to fabricate it today. So this is what everyone should be using to connect all of the I2C devices to the microcontroller. Okay, and so all of the SCL pins, they're all common. All right, all of the SDA pins are common, 5 volts common, ground's common. So now all you have to do is, and it doesn't matter which one of these you connect, but say you wanted to connect the default pin straight from the motherboard into this first row, and then you can connect your LCD to this one and your real-time clock in this one, and so on and so on. All right, so there you go. I'm glad it came, and I'm glad that we have that little board. It's going to help us out a lot. All right, the next video I'm going to show you, we're going to use this little guy, and we're going to put 3 things together. We're going to put, or perhaps just 2, we're going to use the real-time clock and a I2C LCD screen. All right, or maybe 2. Stay tuned to find out what we do.